inside an atom. In this video we're going to have a little look at what's actually inside an atom. So we've spoken about the periodic table of the elements. All of these are the elements that we know of that exist, and of course if we cut those elements down into their smallest building blocks we are left with atoms. So an atom is the smallest building block that makes up everything. For example here, magnesium. You can see magnesium makes up all of these different things. Pencil sharpeners, there's a piece of magnesium here. The element's known as magnesium. It looks like this with lots of atoms next to each other. And remember, an element is just one type of atom. If we cut that down into the smallest possible building block, we get one atom. The atom is the smallest building block. Everything is made up of atoms. So what is inside an atom? Okay, we start off with the centre of the atom, which is called the nucleus. You've heard this term before in cellular biology. It's a different nucleus than in a cell. Inside the nucleus live a positively charged particle called a proton and a neutral or no charge particle called a neutron. They both live inside the nucleus, which is in the centre. The positive proton, the neutral neutron. Around the outside of the nucleus, we have negatively charged particles that are called electrons. Positive protons, neutral neutrons, and negatively charged electrons. Be very careful. Neutrons are not negative, electrons are negative. Neutrons are neutral, electrons are negative. Electrons are very small particles, tiny, tiny small particles, whereas protons and neutrons are a little bit bigger. But there's a great analogy that they give, that if you were in Melbourne at the MCG and you placed a tennis ball in the centre of the MCG, that would be the equivalent of the size of the entire nucleus, and specks of dust sitting on the seats around the outside would be proportional to the size of an electron. So electrons are very, very, very small, and so are protons and neutrons really. They're the size of a tennis ball in the MCG, so comparatively that's very small as well. So when you think about it, an atom is made up mostly of empty space. But you need to remember the nucleus, proton positively charged, neutron neutral charge, and around the outside we have negatively charged electrons. Okay, so just as a reminder, proton has a positive charge, a neutron a neutral charge, and they both live in the nucleus, and an electron has a negative charge. And they live in shells around the outside of the nucleus. Okay, number of protons. How do we find out how many protons an atom has? Okay, looking back at the periodic table, you'll always see that there are two numbers written with the element. There's the element symbol, and there's this number here, which is called the atomic number, and there is this other number underneath, which is called the mass number. The atomic number equals the number of protons. The mass number is equal to the number of protons plus the number of neutrons. And at the end of this video, I'm going to show you how to use the mass number to work out the number of neutrons. But at the moment, what I would like you to remember is that the atomic number, so the smaller number of these two numbers, is equal to the number of protons in that atom. So the atomic number is 12 for magnesium. So the number of protons must be equal to the number of electrons in a neutral or uncharged atoms. So if the positive charge must always equal the negative charge in an uncharged atom. So the protons equal 12. We know that by looking at the atomic number. The electrons must therefore, in a neutrally charged magnesium atom, so just an atom that has no charge, it must have 12 electrons. So it's 0 overall charge. So you can remember that in any element that you see on the periodic table, or any atom that is uncharged, the number of protons will always be the same as the number of electrons, and we find out the number of protons by looking at the atomic number. Okay, so we can have a look at the periodic table now, and I can point to any element, for instance lithium, and you'll be able to tell me that it has 3 protons and 3 electrons. If I look at carbon, it has 6 protons and it will have 6 electrons in an uncharged atom. Let's have a look at a harder one. Gold has an atomic number of 79, so it must have 79 protons, and in an uncharged atom it will have 79 electrons. So it's the smaller the number here will always tell you how many protons and how many electrons in an uncharged atom.